dataset I have selected to talk about today is our Sawgrass above ground net primary productivity dataset. Net primary productivity is a measure of new plant tissue that is added as the plant grows. And what the plant does is it takes energy from the sun and it uses that energy to take carbon dioxide from the atmosphere and make new plant material. That is what we call net primary production. We call it above ground net primary production because what we're measuring is growth of the plant above the soil surface. So we're not actually able to look at what's going on with the roots with these measurements. But ANPP is an important measure because sawgrass is the charismatic macrophyte of the Everglades, and it is covering more than half of the remaining system. The method that we're using, we actually developed for sawgrass in the Everglades, and it is a non-destructive method. It means that we don't actually damage the plants when we take our measurements, and it is the best way of estimating actual primary production in this kind of a wetland setting. It's important that we have long-term data sets for above ground net primary production of sawgrass. First of all, because sawgrass is the dominant macrophyte, the charismatic plant of the Everglades, and also because of the changes that people have made in the Everglades in terms of building canals and draining the system. Water levels are much lower now than they were 50, 75 years ago, and sawgrass actually originally grew in the Everglades only on ridges, only on high spots. And as the water levels went down with drainage because of human canal building, sawgrass actually has expanded its extent into the deeper water areas, which are called sloughs. And so the reality is that with Everglades restoration making the Everglades water deeper again, what we expect to see is sawgrass cover essentially decreasing as the sloughs get deeper and sawgrass loses out to plants that prefer to grow in deeper water. And a great example of that is right out here. We have sawgrass right behind me, and then right beside it this is a slough. You can see that there are deeper water plants such as lily pads growing in the deeper water. So as this slough gets deeper, the sawgrass should actually show lower productivity, and it should back up, if you will, as the slough gets wider. Well, the plant that actually does take its place in certain situations, and there's some of it that we can see from where we are standing, is cattail, typha. And there's some typha over here. There's also some typha over here. And typha is a native plant. There's absolutely nothing wrong with typha. It grows in the Everglades in places where nutrients are higher. Soil nutrients are higher. So for example, around alligator holes, where animals tend to congregate in the dry season, nutrients are higher in these areas because of all the animal activity, and you often see cattail growing there. Further north in the system, up towards Palm Beach County, there's a big problem with water quality because water is coming in from the sugarcane fields of the Everglades agricultural area, and what that is doing is enriching the soils so that cattail actually outcompetes sawgrass over hundreds of acres of the Everglades. That's not a big problem in Everglades National Park yet, but it's a main reason that we track water quality all the time, because we want to be able to detect problems with nutrient enrichment in Everglades National Park wetlands before they become a problem. What it does do is affect the entire ecosystem. So a cattail-based system, cattail-based marsh, is not a peat-building marsh. Cattail does not build peat. Peat is the organic soil that underlies sawgrass that we see here and the sloughs that we see here. If cattail takes over and you have a monoculture, what we call basically nothing but cattail growing in a given area, what you find is that the soil becomes very mucky and slushy. You lose that organic peat that sawgrass actually builds up. And the reality is that peat is important because it's a very low nutrient peat that overlies the limestone and overlies the Biscayne aquifer, which is where people are drawing their water from. And so effectively, the sawgrass peat that is covering the marsh out here is a biological filter, if you will, for water that's recharging the Biscayne aquifer and providing water to 6 million people in South Florida. Okay, so you can download the Sawgrass ANPP datasets, and then we've talked about two other environmental variables that control sawgrass productivity. The first one is water level, and we have hydrology data for water level at all of the sites where we collect sawgrass productivity. And so if you looked at sawgrass productivity over the years, relative to water level over the years, you would expect in years where we have shallower water that sawgrass productivity would be higher, and in years with deeper water, sawgrass productivity would be lower. The other thing that we would expect is a relationship between soil phosphorus, because phosphorus is a limiting nutrient, a relationship between soil phosphorus and sawgrass productivity. So that if you have higher soil phosphorus levels, you should see higher productivity by the sawgrass. So the dominant nutrients that control plant productivity and actually control ecosystem productivity are nitrogen and phosphorus. In any given ecosystem, one of those two will be of low enough level that it is actually controlling the plant productivity. And you can tell something like that by going in and, for example, fertilizing a small plot. If you fertilize it with either nitrogen or phosphorus and you see a growth response, then the element that you added, either nitrogen or phosphorus, is in fact demonstrated to be the limiting nutrient. We know from a great deal of research in the Everglades that phosphorus is the limiting nutrient.